In this case, we will talk about the static class, method, and functions. And so, what is the static class, or the methods, or the functions? Some methods can be used without creating any instance of class, which means that, for example, you want to square of some numbers, and so we can use it because we don't need to create any variable. We just operate with the multiplication or the another terms, just like this one, and so we can build it. Okay, so which means that only methods are required for the operation. Okay, at this time we can use the static methods. Can be performed in the class. Okay, in order to understand this property, we need to give the examples. For example, we want to design the class of date. Okay, so def init self day month and year, and self day is equal to the day, self month is equal to the month, and self year at the year. Okay, and we can write the static method in here. Just like this one, and so def is leap year with a year. Okay, this is the is the remained year calculation. Do you understand the leap method in here? For example, the return year 400 is equal to the 0, or year percentage 4 0, and year percentage 100 is a remained, or the leap year, equals 0. Okay, and so the self is not used even if in the class. Okay, and so we don't have any data related to class. Okay, so the result date can directly code based on this definition. Okay, date is leap year, for example 2000, and so we can print the leap if result else not. So this is a leap, but for example if we use the 2001, it's a not leap. Okay guys, and so if we design our method by using just this keyword by static method, and so we don't need to use the self keyword even if the class possesses this function. Okay. How about this one for the static methods? Class date def init self day month and year. Okay, self day is equal to the day, and self month is equal to the month, and self year is equal to the year. Okay, and and so the def this can be called, but in this case we need to give the self keyword because it's not a static method. Okay, and so the print date and date. Okay, and so the format self day, self month, and self year. Okay, and so at this case we can give the same static method just like this one. Okay, so the result is equal to the what, to the date is leap year 2000, and this is the same syntax with this case. Okay, and after that we can give the date, for example 11 and 100 990. Okay, and so date this can be called in here just like this one. So, or we can give the date this and date. These two one is identical, guys. Okay, identical. And after that we can resolve with the what with these terms with the same idea. Okay, but what's the difference between the static methods and the what and this methods? In this case, date possesses this function, but we need to give to what, to the self keyword in here, self. And so this is identical with the previous one, but in this case, this date is leap year, don't have or don't require to the what, to this self keyword. This is the main difference between what the normal class methods and the static methods, guys. Okay? Any question about it? Okay. Class sample def foo self print foo. And also we can give the static method def bar, and also we can give the self in here. It's the bar. Okay, and so s sample can be generated in here. We don't have any inclusion, but just see that f foo can also be written just like this one. The foo is seen on the page, but s bar, if we call the s bar, and so just see that sample bar missing one required positional arguments, which is equal to what, to the self. Okay, but we can remove these terms, and so we can call this static function method. But if we give the self method in here, there's no syntax error. But in this case, we have the runtime error. Exception. Self is a parameter right now, not a class parameter. Okay? For example, if I choose to use the A in here, see, sample bar missing one required positional arguments. Okay? This is the attributes, not a class variable in here. Okay? So we can continue with another class methods in here. The class sample def init self and self a is equals to the 10, for example. Okay, and after that the def foo can be built with with the self, and so the print foo. Okay, and also static methods can be given in here, def bar, the print bar, and also we can write the class method keywords in here just like this one, def tar and clc and print tar. Okay. This class method is different from the static method. We run this code, we don't have any error in here. And so s sample and s foo can be called in here, and also sample bar can be called just like this one, and also sample tar can also be given in here just like this one. And so what is the difference between the two of them? This class method is not a static one. So, for example, if I choose what to put a in here, and so sample tar missing one required position argument a given in here. But if we using the CLS type self-sample keyword in here, and so we don't have any error in here. But also we can call the s bar and s tar in here based on this information. The static methods can be called either using the instance of the sample or the sample itself. Just like this class method can be called with the same one, guys. Okay? So, in this case, it's 5. We should continue with the decorators. It's a tough one to understand that, the decorator. This is conditioning the function and class related to specific features. Okay? And also we can write the sum at should be given in here and foo, and also class methods can also be used in this decorator function. Okay? For example, the foo f can be given in here, and so print foo function and return to the f. Okay? We can return to these values, but in this case we can create the decorator by using the add foo function in here, and def bar, and so the print bar can be written just like this one. And also we can write another bar in here in order to understand the property of this decorator. After that, the bar is equals to the foo bar. Okay? So at this case, if we run this code, this foo is assigned with a bar. Okay? But just see that this foo is called to the to this foo or other one. See, at foo function is not calling to the to the bar value. See, in the first place we call the foo, and so we see that we have the foo values in here, and so this must be called in here, right? This is called, and after that we need to return to the f. F is equals to the bar, right? And so if this is called, then either this one or this one must be called, but this is not the case because the add foo decorator conditioning this function to generate the read itself in here. This is the decorator. And so if this is too much for information, and then we can create another examples in here in order to understand this property. Def foo f and also def g function can be returned with the print. This is the internal code, okay? And also f can be called in here because f is the another function, and also we should return to the g in this case, okay? And so add foo is the decorator, and def bar, the print bar can be called in here. And after that, if we call the bar just like this one, just see that what happens. What will happens if I run this code? This bar is code, okay? But this bar is related with with the foo, and also this foo is calling in here just like this one. And see, this foo returns to the returns to the g. And so this G is called in here again, and so the print internal code is calling right now. Okay, this is the basic definition for the what? For the decorator. It's hard to understand this property, but if you try to create the example session about it, and so you can say it. But just see that this bar is called and foo is also called right now with this function. Okay, and so how we can utilize this property right now, because there must be a purpose to define this one. If you don't understand right now or up to now, and so we can use this function log file is needed when it is code. Okay, we can create a log file in here. For example, if we import datetime as dt, okay, def mylog file open this file conditioning operator log file txt with the written objects given in here, and so that log can be given in here just like this one, file dot write function called at plus str dt date time now. This returns to the current time values in here plus this one. Okay, and also we should call the f because this is the decorator function. Okay, if this is the case, we open the log file in here, and also this log calls to f because the mylog returns to this one, just like in the previous example. This is decorator definitions. Okay, and so mylog can be given in here def foo, the print foo is given in here, and after that if we call the foo function just like with the previous example, and so this foo is code, and so if foo is related or linked with the mylog, and so this mylog is as well code but based on the foo f, and so we open the file and deflog is called in here, and at this case when we call the foo function we log at this case in here just like this one. See log file in here, this is the log file. Okay, so but this is empty right now. Okay, but what happened if I call 3 times in here? See, no, I'm sorry, I didn't pass this value in here. Okay, you can return to the log values in here just like this one, and so this is written and this is written. Just see that the log and return log f and f is called right now, and so when I want to use the foo function, this foo function is related to the what or linked to the what to the mylog, and so at each case we call this function and then we log this file based on these operations. Okay, this is how we can utilize this function based on this information. So we have the decorator class properties is assigned to the class. Okay, class foo def init self, and f is a function, and we need to return to the none. Okay, print first process self f equals to the f, and also def call function can be called in here. Call is related to the what? Is related to the open and parenthesis operator. Okay, we overloaded it right now, and so print internal code is given here. After that, add few def bar can be used in here, so to print bar. Okay, and also we can call the bar right now. Just see that this is what, this is the decorator class, guys. Okay, this is the decorator class, and so when we call the bar function, this bar is related to what with the foo, and also this foo is called to the what class of the foo. And after that, if we run this code, first of all, the initialization function or the class is created based on these terms, and after that, the internal process or internal code is calling, because this bar uses this operator, overloading at the code. Okay, any question? Please revise the decorator class and utilization. This is an advanced topic, but it's a necessary topic, I think. And also we can create another example. The foo can be defined with what the print foo and return C. Add foo and class sample def this given in here and print this. Okay, after that, S is the sample. Okay, this is a class decorator, but if we create this function, and so we will create or link also the foo function in here, just like this one. The foo automatically called by the compiler. Okay. Okay, and also as this can be called in here. This is the basis of the what of the decorator utilization, guys. So week 12 3.5. Okay, the next topic, we need to get the exception handling. What's the meaning of the exception handling? In one time, there may be some errors, such as zero division, reaching unknown addresses, or maybe we have this kind of situation, 1 divided by 0. In this case, we have the 1 divided by 0, so we have two integer values. Syntaxically, there is no error in here, but in the runtime, this could be equal to what? The infinite value. This is not proper to run this code. And so, in this case, it is called the exception. We throw the some parameters in here, in which it can catch these kinds of errors. Okay? But what is the syntax of this term? Basic syntax is try. We need to give the some suites in here, and also except. We need to give the type of the except, and also as type name should be given here, and also suite and also except type as type name. Okay, and the suite. And after that, we need to give the some codes, okay, and we need to give at the end of this code the final and the suites. Okay, this is the basis of the exception handling mechanism. But in order to understand this property, so we need to build the example sessions. Okay? As x is equal to 0, and while, for example, x is not equal to the minus 1, we can build what a try. Answer s input give a value. The return value of the s is the str. Okay, and x integer s. Okay, and so the print s. Not to that, except value error. We can write this, and so we can print what this is not a number. And after that, else the print program is end. So if I run this code and then give a value, for example 5, this is not a number, 5, we have no error in here, guys. See, 5, but if we use the astas, and so this is not a number, this exception is running on this code. Okay, but we have also built this program just like this one. We can remove these terms. Okay, can write this, and after that, if you run this code and then 5 can be given, but if you put the s of us and so x int s inbuilt literal for int with base 10, which means that we cannot convert this value. This is a runtime error, but we can't catch it in here. But in the previous case, we could catch it with the basis of what except value error. Do you understand what I'm saying in here, guys? Do you understand the property of these terms? Any question? Yara, do you have any question? Mustafa? Okay. This is the difference. So, after that, we can build the depth field. We can build what the 10 plus I. This is a syntax error. But in order to catch these mechanisms, and so we can print what enters the try statement. Okay? And so we can call the foo. And also we can build what accept value error here. This is the print of what the value error happens. Okay? But we can build what the many exception error. The print type error occurs. Okay? And also we can build what print continues. So if I run this code that enters the try statement, type error occurs is given in here, not the value one, guys. What's the reason of this terms? What's the reason? Because we don't have any value error in here. Just type error in here, because the 10 cannot be summed with the what? With the Ali. Okay? That's it. Do you have any question? So this is the case, the def foo, the print foo begins can be here, and we can call the bar, and we can write also the print foo ends. Okay, and also we can define the bar, print bar begins, and also integer value x. Okay, and show the print bar ends. Okay, this is the case. And so try can be built in here, and so the foo can be called just like this one. And so except value error can be given in here, and so the print value error exception. And also we can copy these terms in order to catch the other parameters in here, the type error, index error. So if I run this code, foo begins and the bar begins are called, but just now this one, until it goes to the what, the integer x value, this code is what is called, is run. Okay, this is important because if we have the try and catch block, we can prevent to the what, to the collection of the R codes, guys. Okay, any question? Okay, so in this week that's it.